To start off, we will go over the definition of a few terms. A gene is a section of DNA that holds instructions for making one protein. These proteins are used to express specific traits. Alleles are different versions of a gene. For example, big A, big A, or small a, small a. A chromosome is a long strand of DNA coiled and wrapped up that contains many genes. Epistasis is when two different loci contribute to the same phenotype in some unexpected manner. We will take a look at, for example, duplicate dominance epistasis. This is when having at least one dominant allele at either locus will result in the same phenotype. Genes that mask the action of another gene are said to be epistatic to the masked gene. Take a look at what happens here. Only when we are homozygous recessive at both loci will there be a different phenotype or no product at all.
Duplicate dominant epistasis. Here we will see that our starting point is Carmichael Residence Hall, where if we have the big A allele with the small a allele, or both homozygous big A alleles, we can get to our destination, UNC hospitals. Or if we have the big B allele with the small b allele, or homozygous big B, we can also get to our destination. However, we are homozygous recessive for both A and B, where there's a broken chain, or if the car is not working, we cannot get to our destination. If we are homozygous recessive for the B allele, oh no, the car won't start. Well, since the car didn't start, we have our bike here, and our bike will take us to work. If we are homozygous recessive for the A allele, the bike chain has popped off. If we are heterozygous for the big B, small b allele, or if we're homozygous big B, we can drive the car to work. If we are homozygous recessive for A and for B, neither the car nor the bike work, then we can't get to work. I guess I better call in to work and let them know I'm not coming.
A dihybrid cross is an experiment in genetics in which the phenotypes of two genes are followed through the mating of individuals carrying multiple alleles at these gene loci. A dihybrid cross, therefore, is the mating of two individuals, both heterozygous for two different genes being observed. In a duplicate dominant epistasis dihybrid cross, we see that we will always be able to go to work as long as we have a functional bike or a big A allele or a functional car, big B allele, at either loci. Therefore, here we can add 9 plus 3 plus 3 together since they all give the same phenotype. This equals 15. The only time we are not able to go from the residence hall to the hospital is if we are homozygous recessive for the A and B allele, which equals 1. This is a 15-to-1 ratio, contrary to the 9-to-3 to 3-to-1 ratio, indicating that epistasis is occurring. If we make a different cross with different genotypes, we can see that this too would produce a different ratio, a 1-to-0, where we will always be able to make it to work.